All right, 3.7, distributive property. To expand an expression means to remove the brackets and simplify. So when we expand and simplify, we do this. To do this, we use the distributive property. So for example, A times B plus C is equal to AB plus AC. So the distributive property, we take A and we times it to everything inside so that A gets multiplied by B and A gets multiplied to C. So A times B and A times C. Now, you're going to be asked to multiply the monomial by each term of the polynomial and multiply the coefficient and apply the exponent laws to the variables. So for example, I want you to understand that when you multiply monomial, you have a monomial on the outside, you multiply to each term of the polynomial inside the brackets. Second part is that don't forget, you have to multiply the coefficients together and then you apply the exponent laws to the variables. So we'll see examples of what I mean by this, okay? Here we go. First example, expand the following. So we have a bunch of questions here that we're just going to expand. So 3 times x plus 5. 3 times x is 3x. And 3 times 5 is plus 15. Next one, minus 2 times 2 minus x is going to be negative 2 plus x. Now don't forget, you're also giving the sign to each term. So here's another one. 4 times 3x, 4 times negative 2y, 4 times 7. So what you're going to have with that last one, we'll see in just a second. Now going back to this one, notice here that the x comes first. Here, the x is not first. Algebraically, it is important that we try and keep consistent by writing the term with the highest exponent first. Term with the highest degree first. X comes first, and then minus 2. So we're just reversing the order. Move the plus x in front so we get x minus 2. Part C. 4 times all of the stuff inside the brackets. That is, 4 times 3x is 12x. 4 times negative 2y is negative 8y. Plus 4 times 7, which is 28. So, again, we take the 4 and we multiply it to each piece, and what we discover is none of these have like terms, and they shouldn't because the original didn't have like terms. Let's look at some harder examples. Looking at these, we can see that it starts to involve variables times variables. So let's look at the first one. This might seem hard, but really, folks, all it is that the negative 4 is brought to the front. If you bring it to the front, then you can just multiply to each term on the inside. So you can bring the negative 4 in the front and multiply to each term on the inside. That is negative 8y minus 20. Now, don't forget that this negative also gets the sign, so don't forget it's negative 4 times all of those values. Part E, x times x is, hopefully you're thinking, x squared. X times minus 3 is minus 3x. And that is the expanded form of part E. F, we're looking at p times p squared, which is p. Okay, let's look and see what was written here. A lot of times students have difficulty with understanding x times x. X times x, folks, is going to be x squared. X times x is, if you remember the exponent laws, x has an exponent of 1. This x has an exponent of 1. When we multiply it, we add the exponents, and that's where we get x squared from. Let's try the next one here. P times p squared. what will that give us? Well, we have 1p here and 2 over here. So total of p cubed. And then p times minus 2p is minus 2p squared, plus 1 times p, which is p. So that is the expanded version of this. So again, p times p gives you, p times p squared gives us p cubed, p to the power of 3. P times minus 2p is going to be minus 2p squared, because it's p times p, which gives us p squared. And p times 1 gives us p. Now, when expanding and simplifying expressions, you must use the distributive property to remove the brackets, collect the like terms, and here's an example, expand and simplify. So here's a bunch of different multiplication values, and we need to expand and simplify each one of these examples. So let's do that. So with this case, what we have is negative 4 times x and negative 4 times positive 3, which gives us negative 4x minus 12. Then we have the plus 2 times 2x, which is plus 4x, and plus 2 times negative 1, which is minus 2. Collecting like terms, we're looking at negative 12. So negative 4x plus 4x gives us 0, and negative 12 minus 2 gives us negative 14. Next, 3m times m gives us 3m squared. 3m times negative 5 gives us negative 15m. Minus 2 times m squared is minus 2m squared, and minus times minus m is plus m. Collecting like terms, we have m squared, 3m squared minus 2m squared is just m squared, and minus 15m plus m is minus 14m. So 3m squared minus 2m squared is m squared, and minus 15m plus m is minus 14m. All right, moving on. Another example, here we go, a little harder. Here we go. 1/2 times 2w, we expand this, and then we expand this, folks, and then we collect the like terms. So let's do this. 1/2 times 2w, 1/2 times 2w is just w. Why is it just w? Most of you would be like, what is going on here? So let's look at it. 1/2 times 2w, just like that, means that this is 2w over 1, if we look at it this way. And remember, we talked about earlier is how to reduce our answer. So we'll end up with just w. For those of you that don't remember how to do that, we may want to multiply, let's say, the numerators and multiply the denominators. And you can see that when you multiply the numerators and multiply the denominators, you get 2w over 2, which results in just w. And that, folks, is how the answer is just w for that first one. Okay, minus 3. So minus 3, the reason it is 1/2 times negative 6, which gives us minus 3. 1/2 of 6 is 3. Minus 2/3 of 9w. That gives us negative 6w. Let's practice and see why that's the case. Minus 2/3 times 9w. Remember that we put the 9w over 1, and we get negative 18w for the numerator, and the denominator is 3. Negative 18w over 3 is negative 6w. So that is how we got negative 6w for this question. Okay, moving on. Negative 2/3 multiplied by negative 6 gives us positive 4. Let's look at that and see why. Negative 2/3 times negative 6. Remember, we put that over 1. So the numerator turns out to be 12. The denominator turns out to be 3. 12 divided by 3 gives us 4. So our answer here is 4. So that's why we have plus 4 as our final answer over here. Okay. Now we need to collect like terms. W minus 6W and negative 3 plus 4 gives us negative 5W plus 1. Part D, here we go. Let's look at the last one. Part D, negative 2x times 2x, negative 2 times 2x is negative 4x. Negative 2 times positive 5 is negative 10. Negative x times 3x is negative 3x squared. Negative x times negative 5 is positive 5x. And positive 4 times x squared is positive 4x squared. And positive 4 times negative 1 is negative 4, minus 4. Collecting the like terms, we get the x squareds that go together, and that gives us x squared. That is negative 3x squared plus 4x squared gives us x squared. Negative 4x plus 5x gives us plus x. Minus 10 minus 4 gives us negative 14. And that, folks, is our final answer. Moving on. When simplifying expressions that contain brackets within brackets, i.e. nested brackets, start with the inner brackets and work your way outwards. For example, example 3, expand and simplify. What these involve is a double set of brackets. And a lot of students have difficulty with double sets of anything. Well, we're going to go through this slowly. All right. With this, we have, some of you might be wanting to attempt to make 2 plus 5. And I will say no right away. We say no because this 5 is actually attached to something. And bedmaster rules state we have to multiply the 5 out first before we can add anything. And again, why we're doing that is, remember, there's double set of brackets, so we look inside each set of brackets and see what we can do. Inside these square brackets, we're going to simplify, expand, and simplify inside the square brackets first. So we leave the 3 outside, we leave the square brackets, but inside here we're going to get rid of those round brackets. That is, we have 2 plus 5 times 2x, which is 10x, and then 5 times negative 1, which is negative 5. Now, you have 2 choices. You can simplify what's inside here and then expand it with the 3, or expand first and then simplify at the end. It's up to you, folks, but I guarantee you'll get the same answer either way you approach it. What we're going to do is, just to make things easier, is we're going to just expand these values out. So 3 times 2 is 6. 3 times 10 is 30x. 3 times negative 5 is negative 15. So we have 6 plus 30x minus 15, which is 30x minus 9. The next part, right here, looking at these values right here. So we have a 3 on the outside, square brackets, and within those square brackets, we have another set of brackets. What we need to do is expand these out before we can touch it with the 3 over here. So 3 on the outside, and what we're going to do is we write 5x, and then we minus 3 times 3x, which is minus 9x, and minus 3 times negative 1, which is plus 3. Once we expand that out, we then collect the like terms. So that is, we get not collect the like terms, we're going to expand it out first. 3 times 5x, which is 15x, 3 times minus 9x, which is minus 27x, and 3 times 3, which is plus 9. Now we're going to collect like terms. 15x minus 27x is minus 12x. And then we have the plus 9 left over. And that, folks, is how you simplify a question with nested brackets. All right, that was a long one, and that's the end of the lesson. Have a numerical day.